Good morning, everyone. Myself, Vivek Pangade, Assistant Professor, Department of ISC, Savitri Institute of Technology, Ajankunte, Bengaluru. Today, we're going to see the concept on relational model constraint and relational database schema. Basically, what is constraint? Constraint is nothing but a restriction. Constraint is a restriction that we are applying on we're applying on the database. Either we can apply a constraint on the attribute, or we can apply the constraint on the rows. So, what is constraint? Constraint on database can be generally divided into three main categories. One is inherent model, or besides implicit constraint, explicit constraint, or semantic constraint. So, first is implicit constraint. Implicit constraint, by the name of it, we can say that implicitly, right? So, whenever the software is developing, whenever the DBMS software is developing, the software developer is going to add some of the constraint. While developing the software, some of the constraint is going to be added by the software developer. Those type of constraint we say it as an implicit constraint, right? So as the user, we can't add that constraint to the database. So or we can't remove that constraint from the database. It is inbuilt. It is inbuilt when the software developer is developing this application. Then at the time only he has added some of the constraint. One best example is that while creating any of the database, so we will give integer value, like for example student id integer, or we can take it as student phone number. Limited value given for the integer data type. So this is the one best example of implicit constraint. When it comes to explicit constraint, as we the user, we giving a constraint to any of the attribute like primary key, foreign key. Like these are some of the constraints we are adding to that attribute. And for example, student ID in bracket we will give 10. So what it indicates, the student ID should contain 10 characters. It should contain 10 characters. Before 10, below 10 character or above 10 character, your database will not accept that value. Student ID varchar of 10. This is the 10 is the constraint I am adding to that attribute student ID. This type of constraint we say it as an explicit constraint. So explicit constraints are given by the users who are using the database. While creating any database or while using the database, some of the constraints we're going to add on the attribute, those type of constraints we say it as explicit constraint. Last one is the semantic constraint. So semantic constraint is nothing but semantic thing, but if we give a constraint to particular attribute, the whole schema will be get changed. For example, adding a primary key, I will make student ID as a primary key. So there in the schema, it will display there one schema how it will be created. Like for primary key attribute, we should not place it as a null value. We cannot insert a null value, and a unique value we need to give to that primary key. So this is the semantic we're adding to that attribute. So that type of constraint we say it as a application based constraint or semantic based constraint. Apart from these three, we have many constraints like domain constraint. So domain constraint means, as I said in the previous videos, domain, nothing but the values what we're giving to the column, those we say it is domain constraint. So what is the constraint we are giving to domain means, whatever the values we are giving, all values should be atomic value. All values should be atomic value. We can't assign a multiple value to single attribute. For example, student ID, I can't write like 1 comma 2 comma 3. It becomes a multiple value for the same attribute for the first tuple. It is not allowed. To avoid that one, we're going to add some of the constraint to that attribute. That constraints we say it is the domain constraint. It is age of a person. Here they give age of a person. Age of a person is age of a person will be only one value, atomic value. For example, 28, 29. A same person cannot be having a multiple age. It doesn't have a age, multiple value for the age. So this type of constraint we're going to apply, that we say it as a domain constraint. The next is key constraint and constraints on null values. Key constraint nothing but the constraint we're going to apply like primary key. So whatever the values we are giving to the primary key, so it should be a single value. Single nothing but it should the value should be unique. The same value we cannot repeat to the same attribute if we made that attribute as a primary key. If we made that attribute as a primary key, if we give the same value to the prime attribute or the primary key, so there we're going to hit a constraint called an error called the key constraint. And also for that attribute we cannot place a null value. There also we're going to face a key constraint error. When it comes to entity integrity, reference integrity constraint and foreign keys, these are related to primary key and foreign key values. So each entity states that no primary key value can be null. This is because the primary key value is used to identify individual tuples in a relation. So having null values of primary key, it can also identify the same tuple. So next, reference integrity indicating that it are related to the foreign key. So whatever the values we are giving to the primary key, the same value we have to give with the foreign key, because the foreign key is always referring to the primary key. So whatever the values we are giving to the primary key, the same value we have to give to the foreign key. If we missed that, if by miss we have given a different value which is not in the primary key, then we go into hit the same issue, that is referentiality constraint. So whenever we see the referentiality error in the database, we should come to know that we are making a mistake, that primary key value we are not assigning to the foreign key, we are assigning a different value which is not in the primary key. This is regarding the referentiality constraint. So one example here, like as I said, the set of attribute FK in relation schema R1 is a foreign key for the reference relation R2 satisfies foreign rules, right? So the attributing function foreign key has the same domain as the primary key. So if we are giving a foreign key and the primary key, so whatever the data type and the constraint we added to the primary key, the same data type and constraint we have to add, we have to give with the foreign key. If it is mismatch, then we're going to face the referentiality constraint. But this one second one. Second one, whatever the values we are giving the primary key, the same value you have to give in the foreign key. Otherwise, we're going to hit the same representativity constraint. So T1 of Fk is equal to T2 of Pk. So tuple 1 of foreign key should be equal to T2 of foreign key. R1 is the referencing relation and R2 is the referenced relation. Referencing relation is the foreign key and the reference relation is the primary key value. So this is regarding the